Hi everyone, welcome back again to Mathematics for Engineering 3, International Programs, Kazakhstan University. Today we're going to talk about it's going to be the second video on the fifth chapter, which is about ordinary versus singular points. Okay, so let's start. Again, we come back to look at this equation b2x y double prime plus b1x y prime plus b0x y equals 0. Okay, we come back to look at that equation, which is to be the only equation we're going to be looking at in this chapter. Okay, the point x0 is an ordinary point if b2 0 x0 is not 0. Okay, and it is a singular point if, of course, b2x0 is 0. Okay, so to check whether or not to check if it's a ordinary point or a singular point, you just need to look at this coefficient b2x. Okay, and then to check whether or not x0 is an ordinary point, you put x0 into b2, and if it's not 0, of course it's an ordinary point, and if it's 0, it's a singular point. Okay, so let's look at this example. Consider x squared y double prime plus xy prime plus 1 minus x squared y equals 0. Okay, for this equation, you can see that this guy is actually b2x, right? This guy is b2x. This guy is b1x, and this guy is b0x. Okay, let me highlight it here. Right. So right now we have that b2x is x squared. Okay. Thus b2 0 is 0, which means that x0 equals, sorry, I can just write x equals 0 is a singular point. Okay, and the other points which are not 0, they are ordinary point. Okay, so guys, again, an ordinary point is the point that makes b0 or b2 0. And as you can see here, right now your b2 is x squared is 0 if and only if x is 0, right? It's gonna be 0 here if and only if x is 0. So x equals 0 is a singular point. And for any other points, for example, if x is 3, x squared is going to be 9, which is not 0, which means that x equals 3 is an ordinary point. Okay, so here we can say that 0 is a singular point and any other points are ordinary points. Okay, let's look at more examples. Okay, it's gonna become clearer once you look at lots of examples. Here you can see that here is the b2x. So we have that b2x is x minus 1 squared. Okay, and b2x is 0 if and only if x equals 0 and 1. Right? If x is 0, of course b2x is 0. If x is 1, of course b2x is 0 as well. Right? So we have that x equals 0 and 1 are singular point because they make b2x 0. Okay, and you know, any other points are ordinary. Okay, next example, bx is e to the x, and e to the x can't be 0, right? It can't be 0 for any x, right? It approaches 0 if x approaches minus infinity, but it never be 0, right? It never be 0. So if it's never 0, it means that for any x, b to x is not 0, which means that all points are ordinary points and no singular points. Okay, all points are ordinaries and no singular points. Good. Y double prime plus x y prime plus y. This means that your b to x is 1, right? Because the coefficient of y double prime is 1, which means that it is never 0. It can't be 0, right? 1 can't be 0 for any x, right? And here it's the same. All points are ordinary points, right? All points are ordinary points and no singular points as well. Good. Okay, let's look at more examples. For example, here, right now our bx is x squared minus 4, which is x plus 2, x minus 2. And this, guys, is 0 if and only if x equals 2 and minus 2. Okay. So when x is 2 or when x is minus 2, b to x is 0. Okay. Thus x equals 2 and minus 2 are singular points. And any other points are ordinary. Cool. Okay. Next example. This one. b to x is x squared plus 6x plus 8. And this guy is actually x squared plus 6x plus 9 minus 1. And that is x plus 3 squared, right? X squared plus 6x plus 9. This one, this term is actually x plus 3 squared from, this formula. A plus b squared is a squared plus 2ab plus b squared, right? Using this formula. And then here it minus 1. And then you use, it's 1 squared, right? This is 1 squared. So you use the formula again. So you get a plus 4 and, x plus 4 and x minus 2. Here you use a squared minus b squared. So you get a plus b, a minus b. A plus b would be x plus 3 plus 1, which is x plus 4. And then x plus 3 minus 1 is x minus 2. Okay, a plus b, a minus b. Good. Okay, so we have that x equals minus 4 and 2. X equals minus 4 and 2. Sorry, it's this x plus 2, sorry. So x equals minus 4 and minus 2 are singular point. And other points are ordinary points. Okay, next example, this one here is similar to the previous one, right? It's x squared plus 6x plus 10, which is x squared plus 6x plus 9 plus 1, which is x plus 3 squared plus 1. But guys, x plus 3 squared, this one is squared, right? It's squared, which means that it's always bigger or equal to 0. Okay, and then you plus 1, so it's always bigger to 0. Okay, it can't go negative, it can't even be 0. Okay, so you don't have singular points, so no singular points, or points are ordinary points. Okay, so guys, let me sum it up. In this video we learned whether or not the points are ordinary. Okay, and if they aren't ordinary, they are singular. Okay, the point is an ordinary point if b2x is not 0, and it's a singular point if b2x is 0. Okay, this clip is so easy, right? But it's quite important because in the next videos we're gonna solve this equation when for different cases. And the first case would be when the point is ordinary, which means that when b0 of that point is not 0. Okay, that's why you need to know what an ordinary point is, because we're gonna solve this equation with different cases, and that those cases are ordinary points, singular point. Okay, so see you guys in the next video, and we're gonna look at how to really solve the equation in the next video when the point we're gonna say around the point, when that point is an ordinary point. Okay, we're gonna talk about that in details later. So see you guys, bye bye.